Hello, welcome. We are going to start a new topics. A resonance condition series LCR circuit. We know that when the voltage across the inductors and capacitors are unequals. So this is our LCR circuit. Ohmic resistance R, inductance L, and capacitance C. And this is our applied voltage. This is the AC voltage and E naught sin omega t. We know that when the voltage across the inductor, that is VL, is equal to voltage across the capacitor, that is VC, is the same, then the maximum current would flow in these circuits. So we know that at VL and VC in the circuits, in all the circuit, in three circuit element, current would be the same. IXL is equal to IXC. If I cancel out this value, so from here we know that XL, XC, their respective value are omega L is equal to 1 upon omega C. If I say that when the voltage are same across the inductors and capacitors, then the condition is known as resonance condition. At resonance condition, the frequency of this AC oscillation, AC alternating circuit is omega r. Omega, if I put the value omega replaced by omega r, from here the value comes out square of the resonance frequency divided by root CL. From here I will be able to find out omega r, resonance frequency of this LCR circuit is 1 upon root LC. So from here we know that the maximum current amplitude, I naught is equal to voltage amplitude divided by impedance. Here our impedance is square root of ohmic resistance plus XL minus XC. So value becomes 0. Since at resonance we have XL is equal to XC, therefore the maximum current amplitude I naught is equal to E naught divided by square root of R square. From here I have, this is the value. Now this current, since our denominator is only R, earlier the denominator this value, the denominator is earlier case is very large value, but in this case the denominator becomes very small value, that is the ohmic resistance. So our current becomes very high. So at this ohmic at this resonance frequency, we have maximum current flowing in the circuits. We also say that when the current is maximum, we know that in the circuit, in LCR circuit at resonance, our resistance only R. I would say that our circuits becomes resistive. In resistive circuits, maximum current would follow, and also the power losses would be only across the ohmic resistance only. So our power consumption, power loss becomes I square RMS value is square root of current divided by or multiplied R. So power consumed in the resonance condition, power consumed by our LCR circuit is equal to I square RMS into R. Also we can write this one, RMS, square of the RMS voltage divided by resistance R. So here power consumed totally only across the ohmic resistance. There is no power losses across inductors and capacitors. So it is very beneficial. We have these circuits. There are many applications of this resonance conditions. We know that at the resonance our frequency is this one. Now we know that 2 pi omega r has the value 2 pi r. Frequency fr is equal to 1 upon root LC. From here I will be able to find out the resonance frequency fr is equal to 1 upon 2 pi root LC. So this is the frequency at which we got the maximum value. That maximum value of the current is I naught is equal to voltage amplitude divided by R. We generally represent the maximum current amplitude I naught and maximum voltage applied in this LCR circuit E naught. There are some important characteristics of series LCR circuit. First one, number one, at resonance we know that capacitive reactance is equal to inductive reactance. Number two, resonant frequency which is represented by fr is equal to 1 upon 2 pi root LC. Third point, in an resonance or at resonance we have maximum current. That maximum current is equal to voltage amplitude divided by ohmic resistance. Fourth point, it has the voltage, and here the voltage E and I are in same phase. The angles, phase angles between them equal to 0. Now fifth point, the series the resonance conditions is happened in all values of resistors. The resonance condition is occur at all values of R. All values of resistance. And the next point, the voltage across the resistors, the applied voltage here, the voltage across the ohmic resistance, which is VR, is equal to the applied voltage, because in such cases there is no voltage. Total net voltage across across inductors and capacitors becomes zero because they are in out of phase. Now seventh point, power consumption. The power consumption here, would be only square of the voltage amplitude divided by R. We can also write in this format, square of RMS current multiplied R. And eighth point, since the current in this LCR circuit and voltage across the resistors are the same, which is therefore the power factor is unity. Here power factor, we generally represent it by cos phi. Cos phi is equal to 1. It means that phi is equal to 0 because current and voltage are in the same phase. Now, ninth point, the voltage across the inductors and capacitors. Voltage across the inductors and capacitors are very high in magnitude by as compared to the applied voltage, as compared with the applied voltage. That's why we can say that it magnifies the applied voltage. Our series LCR circuit can magnify an applied voltage. And the last point, it is also called acceptor circuit. This LCR circuit known as acceptor circuit. This is known as the acceptor circuit because it accept only one single frequency, that frequency known as the resonance frequency. So it accept the resonance frequency, FR, resonance frequency, and it reject other frequency. If I fed many frequency to this LCR circuit, this LCR circuit would only accept this resonance frequency. We know that at this resonance frequency, current in the LCR circuit become maximum and the impedance become smallest value. That smallest value is the resistance across the resistor. So our impedance here in this case, this is not the impedance. Impedance has the same role as the ohmic resistance. So here the impedance becomes R and our current becomes, maximum current becomes voltage amplitude divided by our resistance. Yes, dear students, please subscribe my channel and also press the bell icon so that it will motivate me to present, to prepare and make good videos on educational show. Thank you for watching.